Hi and welcome to this video, the last in our series on logic and the CPU. And in today's lesson what we're going to do is we're going to start to look at how we might write some programs in a low-level programming language. Okay, so we're going to be writing programs using the fundamental operations of the processor, some of which we learned about last week when we talked about the fetch, decode, execute cycle. Okay, but to get started this week, I've got a couple of questions just to review some of the things that we've learned over the last few weeks. Alright, so let's get started. Here's question number 1. Alright, so again I'm going to do what we normally do every week, and I'm going to give you a minute to try and answer this question. So I'm going to ask you to pause the video in a minute, and I want to see if you can answer this question. Okay, so what I want to know is, can you remember which logic gate this was the truth table for? Alright, so if you want to pause now. Okay, so hopefully you were honest and have paused for a minute. Okay, so what was this the truth table for? Okay, well hopefully you remembered that it was the truth table, of course, for an OR gate. Okay, and well done if you managed to remember that was the truth table for an OR gate. And the easy way to remember that that's the truth table for an OR gate is that it's one or the other or both is on. Okay, so that was the truth table for an OR gate. Okay, now I've got another question for you. Now this is just to recall some of the things that we've learned last week. Okay, so what I want you to do is just see if you can complete the paragraph below. Okay, so we've got the something is the brain of the computer. Instructions from something, the something, then something, the instruction, and then something it. Alright, so again I'm going to give you a minute starting now. Alright, again, I hope you were honest and you did it properly, and you took a minute to see if you get the answers. Let's go through it together and see what you got. Okay, so hopefully you got that the central processing unit is the brain of the computer. Okay, so those first 3 words is the central processing unit is the brain of the computer. It does what instructions from? Okay, so it fetches instructions. So we learned that last week, that it fetches instructions. That's the first part of the fetch, decode, execute cycle. Where does it fetch those instructions from? Well, it fetches instructions from main memory. Okay, and some of you might remember that's also called RAM. Okay, so it fetches instructions from main memory or RAM. So we'll finish off then this last sentence then. The CPU, that's the acronym for the central processing unit, isn't it? The CPU then decodes the instruction and then executes it. Okay, so that's the second and third part of the fetch, decode, execute cycle, that the CPU then decodes the instruction and then executes it. Alright, so well done if you got all of those answers correct. Alright, and that's really, really well done. Alright, so there we go. There are the instructions, just showing you those again. Okay, easy peasy. Okay, so as I said at the start of the video, what we're going to talk about today is how to write programs in a low-level language. So when we talk about a low-level language, we're talking about writing programs using the fundamental operations of a processor, and those are the things that that you were talking about in our 4th week, I think, when we were looking at the NAND game and putting NAND gates together and starting to make things like adders, half adders, full adders, and things like that. Okay, so we know that the CPU is a very complex circuit, and that complex circuit provides us with some fundamental operations that our processor can do. Okay, so when we write programs in a low-level language, what we're doing is we're accessing those fundamental operations, and we're writing programs using those fundamental operations. Now, the kinds of fundamental operations that I'm talking about, the kinds of instructions that I'm talking about, are things that you can see at the bottom of the slide here. Okay, so I'm talking about things like load, store, add, and subtract. Okay, so those are just 4 examples. You can go away. Maybe you've heard of the 8086 instruction set, which is the instruction set we used on early computers. Okay, you can go and do some research on that and see what you can find out. You might want to find out about the Amd64 instruction set, which is what we use for 64-bit computers that we use at the moment. Alright, you will see that that instruction set is a bit larger than just load, store, and subtract. Okay, but what you're seeing there are the fundamental operations of a processor. Okay, so if you want to develop your inquiry a little bit, if that's one of your targets, then maybe go off and use the World Wide Web and see what you can find out about those instruction sets. You could even go and find out, actually thinking about this now, you could even go and find out about the instruction sets that you would find on your smartphone or your tablet. So that would be the ARM instruction set. Okay, so again, maybe have a think about using the World Wide Web to go and see what you can find out about those different instruction sets. Okay, but before you go off and do that, what I want you to do is I want you to have a go at writing some programs using those limited instructions. Okay, now I'm going to tell you now that the programs written in a low-level language, like the one we're going to look at in a minute, okay, are much more complex to write than the ones you've written in Python. Okay, so we're going to have a look at some programs that have already been written. All right, we're going to have a go at modifying them, and then what I want you to do once you've done that is I want you to evaluate and think, well, compare what you did in Python to the programs that you had a go at writing in the low-level language. Okay, why was it different? What made it different? I would imagine that you'd find that the ones written in Python were easier to write than the ones in the low-level language, and maybe you can think about, well, why were the ones in the low-level language more difficult to write than the ones in Python. Okay, but what's important to remember is all of those programs that we wrote in Python, for them to be executed on a computer, they must have been translated into a low-level language at some point. Okay, so although you didn't do it, someone has written what's called a compiler. Okay, and they've created a compiler or an alternative to a compiler, which is called an interpreter. And what compilers and interpreters do is they translate your Python commands into low-level language commands that the processor can understand. Okay, so that's mainly done for you, but you're going to have a go at writing some low-level programs yourself, and from that I want you to evaluate which one you think is easier. Okay, so on this slide that just says what we're going to do. I'm going to demonstrate to you how we're going to do this. Okay, so let me just swap windows, alright, and let me show you what we're going to be working on. Okay, so this is called the little man computer. Okay, what we've got in front here is a little man computer, and this is a CPU simulator. Okay, now it has a limited instruction set, so these are the fundamental operations. So we talked about how a processor has some fundamental operations, some basic instructions that it can do. All right, and these are the ones that the little man computer knows. Okay, now these are quite limited compared to the ones you would find on your 64-bit processor that you use in your laptop, or your ARM processor that you use on your mobile phone or in your tablet. Okay, but from this we can get some idea of what it's like to write low-level programs. Okay, so this is the instruction set, and when you get on this, when you use this link yourself, and this will be posted on Show My Homework, I would recommend that you click this button down the bottom here which says LMC lookup table and have a look at those instructions for yourself. Okay, so make sure you have a look at those instructions for yourself. All right. Now, over here then, on the left-hand side of the window, okay, over here, which is what I've highlighted here, this is our program that's written in our low-level language, okay, and as you can see, this matches the instructions here. All right, so first here we've got we're using the input instruction, STA is the store instruction, okay, input again, and we've got add, and so on. Okay, so this is our program. Okay, now down the bottom here, underneath this this big text box here, underneath here, okay, we've got a little drop-down box, and we can select different programs. Okay, so I'm on the add two inputs program, and I've loaded it, and that's what you can see. Okay, but if you want, you can have a look at how to calculate the maximum of 2 inputs and load that program. Okay, but the one that we're going to stick to for now is just adding 2 inputs. Okay, and we're going to load that program. Okay, so this is the program. So what it's going to ask us to do, first of all, let's look at it with the lookup table. Okay, so basically this program is going to ask the user to input 2 numbers, and then it's going to add them together. Okay, so we're using the input command first of all. That makes sense. Okay, so if we have a look at input, that retrieves the user's input, okay, and stores it in the accumulator. Okay, so when we use the input command, it's going to ask the user to input a number, and then that's going to get stored in the accumulator. Now the accumulator is what's called a register in the CPU, and it's a little memory location, and it's just going to be used to store the number that the user's input. Okay, so that's where it's going to get input first of all. Alright, so it's going to end up in the accumulator. So when we watch this in a minute, you're going to see the number that the user inputs, or that I input. It's going to end up in the accumulator first of all. Okay, so then we're going to do the second instruction, and again, if we look on the lookup table, alright, that says STA, so that's the store command. Okay, so basically what we're doing there is we're storing a value that's in the accumulator, and we're going to put it in the memory address given. So we're going to put it back into main memory. We're going to store it into main memory. Not back into main memory, because it hasn't been in main memory yet, but we're going to store it in main memory, okay, or random access memory. And as you can see here, it says STA, so that's the store command, and then num1, that tells it where to store it, okay. So down here, this says num1, and that tells the computer that this is some data. All right, so this is where we're going to store our data. Okay, so then we're going to get the user to input another number. Okay, and again, like before, that's going to end up in the accumulator. Okay, so that's going to be in the accumulator. And then we're going to use the add command. Now, if we look at the add command again, so that's down here, as the name suggests, that adds the contents of the memory address to the accumulator. Okay, so basically what that does, okay, is that takes whatever it finds at the data location num1. Okay, so it takes the data it finds at num1 and it adds it to whatever is in the accumulator at that point. Okay, and then the final instruction here I think makes sense, or there's two more instructions, sorry. This instruction, the out instruction, just outputs the result. Okay, so we're going to use out, which just outputs the result, which is just there. Okay, and then the final instruction just tells the computer to halt, which just tells the program to end. Okay, so let's run this and see what happens. So we're going to load it into RAM first of all. So this is exactly how the computer works. Our program gets loaded into RAM, and then we can run it. Okay, now I'm going to use this button here. Okay, but you can just use the play button or just click run program here, because I'm going to use this because it's going to take us step by step, because I just want us to work slowly through this program just to see each instruction working. Alright, so I'm going to click on here, and it's just going to do it one instruction at a time. Okay, so I'm going to input a number. Alright, so I'm going to input the number 4. Click OK. Alright, so as I said, when we input, that was in our lookup table, and that number gets stored in the accumulator temporarily. Okay, so you can see that that is in the accumulator temporarily. Alright, and then down here in the log file, look, you can see that we fetched the instruction. That's what we learned about last week. Okay, you can see that we've decoded it, and then we've executed it. Alright, so down here it tells us what we are doing. Alright, so then we'll go into the next instruction, which is this one, STA num1. Okay, so what's going to happen now, alright, is it's going to go and store the number that we've just input in memory. Okay, and it's stored it at this location here, num1. Alright, and if you look at 06, alright, it's stored the number 4 here. Okay, so our number's now been stored in main memory. Okay, so our number is now in main memory, ready for us to retrieve later on. Alright, perfect. So then we'll just do the next step. Okay, so we'll click this button again. Okay, and let's do 5 this time. Okay, so then click OK, and again, look, that's ended up in the accumulator. Okay, so we've got 4 in main memory, that's waiting to be retrieved. We've got 5 in the accumulator all ready to go. Okay, and now we'll do our next instruction, which is going to be this add instruction. So basically what the computer is going to do is it's going to take this number from here, all right, from address location number 6, and it's going to add it to the number that's in the accumulator. Okay, so let's just see that happen. Alright, there we go, and you can see down here the log file just tells us that's what's happened, and we can see it in the current FDE cycle, so we can see the fetch, decode, execute. We can see that it's done that. Okay, so that was the add command. Now it's going to output it. Okay, so now what it's going to do is it's going to take the value that's in the accumulator and output it, so it's going to put it in this box down here. Alright, so let's run that. Alright, and there we go. Alright, so there's that program run. Okay, now I could, if I wanted to, I'll just show you again. Okay, I just did that step by step. Okay, you'll see now that it's still doing, but it's not doing anything because actually the program's been halted. All right, so I can just go load program in RAM. I can run the program, and it will just do all that much quicker. Okay, without just going step by step. All right, so don't feel that you have to do it step by step. You can even increase the clock speed if you're impatient. Okay, and we can run the program again. All right, and it will run at normal speed. Okay, but if you want to review and revise what we learned last week about the fetch, decode, execute cycle, then not a bad idea to take it step by step. Okay, so what I want you to do this week then is have a go at writing some low-level programs yourself. Okay, so what I want you to do, to start with, I don't want you to have a go at writing your own programs. I just want you to modify the programs that are there. Okay, so that program that we've just had a look at adds 2 inputs. Okay, so that takes 2 inputs from the user and adds them together. Okay, so what I want you to do is see if you can modify it so that it takes 3 inputs rather than 2. Okay, and then what I wouldn't mind you having a go at doing, okay, if we just go back to this one, all right, if we just go back to this window, so the second problem I want you to have a go at is this program here, the maximum of 2 inputs. Okay, now what this program does, if we run it, okay, so what this program does is it asks the user for 2 inputs, so let's say 7 and 2. All right, and what it does is it outputs the biggest. So you can see in the output window it says the biggest. All right, so your task for that one is to see if you can you modify that. So can you modify that program so rather than outputting the maximum of the 2 numbers, it outputs the minimum of the 2 numbers. So it outputs the smallest rather than the largest. Okay. Now the final program I want you to write, again, you can use one of the programs that's in the that's already in the Little Man computer. Okay, so if you have a look at the Little Man computer, there is one called a countdown timer. Okay, and if we load this, okay, so what this program does is it counts down. So if we run it, all right, it's very simple. You input a number, and it just counts down from that number like so. All right, so the final program I want you to write is to see if you can modify this program so that rather than counting down, it outputs the first 10 multiples of 9. Okay, so rather than counting down, I would like it to count 9, 18, 27, 36, 45, 54, 63, 72, 81, and 90. Okay, so could you get it to output the first 10 multiples of 9 instead? Okay, so a couple of problems there. Now look, I'm going to say to you that these are tricky problems. They're all designed to be tricky, and so you know this is going to test your risk-taking skills. I'm going to ask you to be a risk-taker. So earlier I was talking about you being an inquirer, but I also want you to try and be a risk-taker this week. All right, so you're going to take risks. You're going to challenge yourself to try and modify these programs so that you can change them and make them do what you want. Okay, but I'm going to be honest here and say that low-level programming is not easy. Okay, so you will find it tricky, but what I want you to do is just try your best and see how you can go. All right, now look, I will send you the link to hang on, let me just show it. There we go. The link to the program I was using, the Little Man computer that was in the browser. I will put the link to that in Show My Homework. All right, so make sure you check Show My Homework, and I will also upload a document where you can put your attempts at writing your own low-level programs, all right, and upload those by the end of next week. Okay, that's the end of this unit. I've hoped you've enjoyed this unit. I've hoped you've enjoyed this year. I look forward to seeing some of you next year for IGCSE Computer Science. And you know, if you're not doing IGCSE Computer Science, but if you ever need any help with any of your technical needs, then please feel free to come see me if we're back in school next year, or just drop me an email. All right, it's been great teaching you this year. I've really enjoyed it, and hopefully we're going to be back in school in August, and I look forward to seeing you all in August. Okay, thank you very much.